Hello students, now we'll be solving memory-based questions of GATE 20. For more video solutions on GATE 20, subscribe to our channel and don't forget to click the bell icon for instant notification.
Hello students, welcome to the GATE Academy. In this session, we will be discussing the questions appeared in GATE 2020 civil paper. Okay, both afternoon and morning section questions we are going to discuss in this session. Okay, so you might have already analyzed the paper. Surprisingly, more questions came in irrigation this time, right? Every time they used to ask more questions from hydrology, then comparatively less from irrigation. This time it was completely opposite. And also one more surprising thing was there. Morning they asked only for 2 marks or 3 marks, like, but afternoon they asked for 7 marks. I think for the first time they are asking this much weightage. First time they are giving in GATE examination, combined hydrology and irrigation. Okay, so morning the weightage was less, but afternoon weightage was higher. So that's what generally I used to tell my students, don't compare with the previous years, don't compare with the first paper with second paper, like that. Okay, every time we have to be prepared with all concepts anytime. Okay, so first I am discussing a question which is asked in the morning paper, which was asked for 1 mark. Very easy thing, asked from precipitation regarding some probability, right? We have done same type of questions, many questions in the classes, in the live sessions and all. What is asked? Probability that a 50-year flood. First of all, what you have to remember, I already told you in many sessions, 50-year flood means return period is 50 year. 100-year flood means return period is 100 year, right? So similarly, they have given it's a 50-year flood means the return period is 50 year. Now, what we have to find out, the probability that such a flood which is having a frequency or return period of 50 year may not occur, means number of occurrences 0, right? May not occur during the 25 years life period of the project. Okay, so simply we know the equations are not, we know in general P of R, any event occurring R times, we know NCR P raised to R Q raised to N minus R. See, direct formula is there. I am just giving you for information. For it is only not only for the GATE 20 aspirants which we have already written the exam. That I will tell you the final answer. In case if you have made the answer wrong, just understand how the equation is coming, so that next time you will not be making any mistake. Also for the 2021 GATE aspirants also. Fine. So NCR, P raised to R, Q raised to N minus R is our basic equation. Now what they are asking, it is not at all occurring. We just have to substitute R is equal to 0. So NC 0, P raised to 0, Q raised to N minus 0. We know NC 0 is nothing but 1, P raised to 0, anything raised to 0 is 1. So the answer is going to be Q raised to N, right? So our intention is, we have to calculate what is this Q. N is already given in the question. How much is N? They are asking for the 25 years of lifetime. Always remember or keep in mind what is the difference between these 2 years. This is the return period. Okay, we are specifying that flood with some year. Na? This is in some duration. It can be 20, it can be 10, it can be 1, anything whatever they are asking. That life period is our N value. So in probability you might have already studied what is the relation between this P and Q and all. We know directly they have not given any probability. Only thing they have given is the time period is 50 years. We know from this time period we want to find out Q, but Q is not directly given. First we have to calculate P value. P is nothing but 1 by T, we know, so it is going to be 1 by 50. But we don't require P here, we require only Q. What is Q? Q is nothing but 1 minus P. And what is P? Probability of occurrence. What is Q? Probability of not occurring. Okay. And T is nothing but your time period. So how much I will be getting? 1 minus 1 by 50. It is going to be 49 by 50. Very easy calculations also. So directly I am substituting 49 by 50 raised to, for how many years they are asking? For 25 years they are asking. If you are calculating, you are going to get 0.603. Right? Very important thing which you have to note it here. In 2 ways I can write. Now, either I can write 0.603 or I can write 60.3 percentage. Now properly check the question. In case it was like this, then the answer will be 60.3. They didn't give that percentage sign there, no? Which means it will be in a decimal. So you have to substitute 0.603. Okay. I don't remember for how many integers they have asked, how many decimals they have asked. If it is only one decimal, then 0.6, two decimals 0.60. They may be giving you a range, okay? Don't worry. In case if you put 0.61 or something, one range may be there. So always remember, this will be our answer. Okay. So next time in 2021 or any other exam, if they are asking this question, properly check in which unit they are asking. In case if they are putting percentage, then you have to convert into percentage. Right? Very easy question, direct formula substitution. Right? I hope everyone have understood. Thank you. Now we'll be seeing the next question which is appeared in the morning session. Okay, that was from, I can tell it's a combination, something irrigation and hydrology, they have combined some concepts, okay. So pan evaporation was given, or crop coefficient was given, effective rainfall and in irrigation intensity or efficiency, sorry, not intensity, irrigation efficiency was also given, 0.5 means 50%, okay. They are asking what is the amount of water required for irrigation. Now see, we know, actually speaking, concept wise it is fine, but regarding the wordings and all, generally they use the concept of pan evaporation and all. We know we are going to multiply with the pan coefficient to calculate the actual evaporation from the reservoir or lake, whatever, right? Generally for that only we are using this pan evaporation and all. They just correlated with irrigation. They correlated with the crops and all, and they asked how much amount of water, okay? Concept-wise it is fine, very easy question to calculate. Simply, we know how much water we have to give through irrigation. We know irrigation is nothing but the artificial application of water. Why we have to give artificial application of water? If the plant is not getting sufficient water through rainfall, through runoff, like that, okay? Now see, evaporation or anything, evaporation like transpiration, anything is a loss for the crops, right? So whatever loss is happening, it can be through consumptive use, anything. Whatever loss is happening, according to this question, they have given only evaporation loss. So whatever is your evaporation loss, that much water I have to give to my crop. Okay, wherever, water body or anything. So how much water is getting lost? So water loss is nothing but they have given that it is 100 mm. But the thing is, they have given, we know if pan evaporation is given, we have to multiply with the pan coefficient to calculate actual evaporation and all. Similarly, they have incorporated with irrigation. So crop coefficient is given 0.4. So I am multiplying with the coefficient. How much we will be getting? 40 mm. So 40 mm water we have to make available for the crop because this much is losing. But what happens? Whenever 40 mm is losing, it is getting a rainfall of 20 mm, right? We have already mentioned that how much water we have to give means it's a artificial application of water. Now, it is already getting 20 mm through the natural resource, means effective rainfall, nothing but runoff, no effective rainfall. So out of this 40 mm, it is already getting through effective rainfall means runoff, okay, not rainfall. It is already getting 20 mm, which means how much we have to give extra, or the amount we have to give. Amount we have to give is 40 mm. Whatever they are asking, I'm just writing the first word. 40 mm is actually required, but 20 mm it is already getting. So we have to give amount that we have to provide, okay, something like that I am writing, or we have to give. How much it will be? Only 20 mm. So only 20 mm we have to give, this will be our answer. But for this question they have given one more additional information, irrigation efficiency they have given. In case that was not there, then the final answer will be 20 mm. But in this case they told some irrigation efficiency, which means if I am giving 20 mm, 50% only will be available there. So finally if I want 20 mm, what I have to give? I have to give double of that, then only half will be remaining here, na? Which means how much we have to finally give? 20 mm. So this is not your final answer. divided by 50 percentage, which means how much it will be? 40 mm. See, if I am giving 40 mm, my irrigation efficiency is 50 percentage. Means out of this, 50% will be getting lost at 50% only will be available finally. So 40 mm, if you are giving, by considering 50% efficiency, we will be getting this 20 remaining. Okay, so for this question, your final answer is going to be 40 mm. Easy question only. I hope none of you have got confused by seeing the crop coefficient and all. Generally, we will be seeing the word pan coefficient to calculate the actual evaporation and all. Na? Hope everyone have solved this easy question. Concept wise, it is very easy to solve, right? Hope you understood. Now we'll be seeing two theory questions which are solved in the afternoon sessions. One was regarding the Muskincum method, right? Muskincum method belongs to the flood routing concept in our miscellaneous chapter, miscellaneous concept chapter. In our classes also, I have told this Muskincum method is somewhat important out of that flood routing method, right? So we know what is flood routing from the upstream flood hydrograph. We are going to generate the downstream flood hydrograph, right? We are having two methods for that: hydraulic flood routing, hydrologic flood routing, right? So in that also we have seen in the flood routing, even if it is hydraulic or hydrologic, we have again divided into two. It can be channel routing or reservoir routing. If it contains some reservoir or some storage facility, then we will call it as reservoir routing. If it is not, we are calling channel routing, something like that. We have discussed in our classes also. So Muskincum method, I told you, very, very important. Previously also they have asked this. So I think majority of your students, I strongly believe 100% of the students have already answered this, because Muskincum method was a previous gate question as well, right? So we know Muskincum method is used for hydrologic, right? So two options we are having: hydrologic. That's why I told you, you have to properly remember whether it is channel routing or reservoir routing. We know hydrologic, for hydrologic channel routing, we are using Muskincum methods, and we have done so many questions also in our classes, in our videos which we have provided also. Equations we are using for calculating the outflow and all equations are there. This time, luckily they have not asked any problems. They have directly asked for 1 mark. Same type of question asked in the previous years also. So we know hydrologic channel routing, for which we are using the Muskincum method. So for this question, this correct option will be this. See, I am not writing in the exact order. So don't think that okay, I think I have put only option A, then it is going to be wrong. Nothing like that. According to this, I am putting B. Okay, may not be in the same order in the gate examination paper, right? Now coming to this super passage, we know we are having different types of cross drainage structure. This is also from the chapter miscellaneous only. The topic will be cross drainage structures. We are having 3 types of cross drainage structure. Either the canal is moving above the drain. Second type means canal is moving below the drain. Third type means the canal and the drain both are meeting at the same elevation, right? Super passage, very important. Previous years also they have asked the question. So both the theory questions asked in the afternoon session was from the previous papers only. Okay, but they asked simply slightly one more data they added, that only. Okay, so super passage, we know in the second category, whenever canal is flowing below the drain, we are having 2 type of cross drainage structure. One is super passage, other one is canal siphon, or simply we can call it as siphon. So we have to understand which type of case 2 cross drainage structure it is. See, first of all, if I am remembering what is super passage and all, I told the students to remember one trick also, super passage. So we can remember regarding underpassage and all. Underpassage means we are going below. So our canal is our main guy. So canal is passing below the drain. That I can finally, indirectly I can choose that option. So this can be one option. This also is having same sentence. So drain is passing. I can remove this option. I can remove this option. Only challenge is to remember what is actually happening there. Okay. If it is super passage, then the canal will be, the canal flood level or full sill level of the canal will be obviously below the bed of your natural drain. Okay, hope you have studied that. If this is your canal water, the full sea level of your canal water will be below, well below the bed of your natural drain. Okay, this is your drain is above and your canal is below. So the full sea level of the canal is below the bed level of the drain. This is the condition for super passage. Now see, if it is not touching the bed, suppose let me tell, if it is touching the bed, what it means? We are touching means it is under some pressure, right? Water is under some uplift pressure. It will act some uplift pressure now if it is touching here. Now see, if it is not at all touching, there is a proper gap there, which means this water is under free flow. I don't remember whether they have given free flow condition or atmospheric pressure, whatever, both are same only. So it is flowing under atmospheric pressure, or I can tell it is free flow. It is not under any other uplift thrust or uplift pressure. So according to these options, in which I have written, the correct option will be option B. Okay. Always remember super passage. For gate 21 aspirants I am telling, read all the things, very important. Mainly they are asking super passage, they already asked two times before. Even in IES exam they are asking, very important. That's it. Just just the definition you have to by heart, nothing else. Okay. Hope you understood both these questions. Now we will be moving into another question which is asked in the afternoon session. It was from hydrograph. As we were expecting, many years they have asked questions from hydrograph, and it was a very high chance that they were asking from hydrograph. As we have expected, a question came from hydrograph, but this time it was for 1 mark only, because the question was very simple. In 2019 they asked one lengthy question regarding the DRH of multiple storms and all, that was for 2 mark, but this time very easy question they have asked, that was for 1 mark. Okay, so what they have given the data of a direct runoff hydrograph. They have mentioned that the base period is 90 hours and the peak flow is 60 meter cube per second. They told that peak is happening at 20th hour also. Okay, so this data is actually not required for us. Just to confuse you, they have given same type of question we have done in the classes also. Okay, just to confuse you, they are giving that. Now see, simply we know the equation runoff depth. Okay, runoff depth is nothing but runoff volume, whatever is your volume of runoff created, divided by the area of catchment. Right, this is our fundamental equation. Just for GATE 2021 aspirants or 20 aspirants who have already attended the exam, who are going to write some other exams, right? SSC is on the way, and IES exam is there in the coming year, or you may be trying for some other exams, state PSCs. I'm telling you, runoff depth, this equation you can use for any hydrograph, whether it is DRH or unit hydrograph. If it is a unit hydrograph, here we are putting 1 centimeter or 0.01 meter. If it is a DRH, this left hand side can be anything. Okay, according to this question, they are asking that left hand side only. So this is what we want to find out. These two data we can calculate it. It can be calculated from the given diagram. We know what is runoff volume, nothing but the area of DRH. Okay, if it is a unit hydrograph, then area of unit hydrograph, like that. So if I am checking what is the area of this hydrograph, what will be the area? It is in triangular shape, na? So triangular shape, I know area will be half into V into H. So 90, see 90 is in hour, whereas that H value will be 60 meter cube per second. So if second and second has to be cancelled, here I have to multiply with 3600 or 60 into 60. 90 hours means multiply by 60, that many minutes, multiply by 60, that many seconds. So this is going to be this much seconds, multiply with 60 meter cube per second. So seconds and seconds will cancel. I will be getting meter cube on the numerator. Okay, what we have done, runoff volume equal to area of hydrograph. Okay, half BH, nothing but half BH. Okay, so divide by area of catchment. How much it was? 300 kilometer square. I told you this 90 was in hour, multiply with 60, it is going to be in seconds. This 60 is meter cube per second, right? So this is second, this is meter cube per second. So these seconds and seconds are going to be cancelled. We are getting meter cube, okay? Don't get confused. Seconds is here only, na? Don't get confused if I am writing here. So seconds and seconds are going to get cancelled. Meter cube is here. So it has to be in meter square. Then only it will cancel and we will get a depth term, na? If it has to be in meter square, we know 1 kilometer is 10 raised to 3 meter square. So 10 raised to 6. That is equal to, then this meter cube and meter square will give my answer in meter. So it is going to be how much you will be getting 0.0324 is your answer. That will be see meter cube meter, that is meter. So they were asking the question in centimeter. I am not writing the options and all. They were asking in centimeter, which means multiply with 100, we are going to get 3.24 centimeter. That's it. So that is going to be our final answer. Right? Properly check in which unit they are asking in the coming exams and all. If it was unit hydrograph, instead of asking the depth, they may be asking you catchment area and all. Then that time we will be putting our left hand side as 0.01 meter and proceeding. Right? Very important concept, hydrograph. This time also question appeared as expected. Hope you understood the solution. Now we will be seeing another question which is asked in the afternoon session. The question was from the chapter Gravity Dam. It is related to the elementary profile topic. Okay, so minimum base width of the elementary profile or our gravity dam they asked. Whenever there is no freeboard, that is the height of water and the height of the dam both are same. Okay, there is no freeboard means such a structure we are calling it as elementary profile. So for elementary profile we are having two equations to calculate what is the minimum base width. In general, we know the minimum base width is nothing but the maximum value of these two equations. First equation is for no sliding condition. Second one is for no tension condition. So we have studied two equations. In the classes also we have done so many questions. And in the gate booster sessions also have mentioned these equations. Hope you have noted that and you have answered that. Only confusion might be coming regarding this C value. Okay, I will explain what it is. So H value directly given 10 meter, height of water or height of dam both are same in this case. Mu is nothing but the coefficient of friction directly given 0.45. G value nothing but the specific gravity of the dam material. Here instead of directly giving that, they have given the unit weight of concrete in kilonewton per meter cube as well as unit weight of water is also given. So we know specific gravity of any material is nothing but the unit weight of that particular material divided by that of water. So they have given both in the same unit. If generally if they are not giving, we assume the value is to be 10 kilonewton per meter cube. But here they have directly given 9.81, so we will be taking 9.81 only. So H is directly there. So once again I am telling this is the general equation. Maybe in any other exam, in the coming any other exams, SSC or IES exam or your state government exams, anything. If they are asking, we have to compare both, whichever is maximum, that is our minimum value. Okay. In this case, particularly they are asking only for sliding. So we are taking only sliding case. Okay. So minimum base width is nothing but directly we are substituting 10 meter divided by mu value is given 0.45. Then what is your G value? I am just writing the steps also here, 24 divided by 9.82. Okay, I am not calculating separately and substituting minus. Now see, this is the case when I was discussing with my students after the exam also, they were telling this got wrong. Actually, the C value majority of the students have written 0. I told you in the classes also, in the gate booster sessions also, even though if C value is not given, generally see if C value is not given, okay, we can assume that as 0. But see, here they have given one point. Assume is uplift is acting. I told you in the gate booster sessions as well as in the class also, in the live class also, I told you either they will mention uplift is neglected or uplift is not considering. Then I can put that uplift coefficient C. C is nothing but your uplift coefficient. Na? I can put C equal to 0. In case if they are particularly mentioning in the question it is acting, which means we cannot neglect it because they have mentioned. Na? Once they are telling us it is acting, assume that it is acting. Then I cannot assume it as 0. Okay. So we know the uplift pressure. If some water is there, then this also will come. We have done questions based on this in the gate booster sessions also. So in this case, the uplift pressure is going to vary like this. So there also I told you the equation is going to be whatever is this gamma W into capital H. Here gamma W into small h. Here it is 0. So it is 0. I told you if you are considering the uplift coefficient also, we are going to multiply with the uplift coefficient then gamma W into H. They told that it is acting. We cannot neglect it. If we can neglect, we are neglecting the uplift. Our uplift is not acting means your C is going to be 0. But here they told that it is linearly acting, which means your C value is going to be 1. So that value you have to substitute here. Maybe majority for the majority of the students, this might be got wrong. So don't worry. I think a majority might have got the wrong answer for this. But for those students who have taken the session seriously, I hope you might have already substituted that one. Okay, I told it clearly in our classes as well as in the gate booster sessions also, right? So that is going to be, see, 0.45, there is no unit. Specific gravity, there is no unit. So only unit of this B will completely depends on in which unit you are substituting your capital H value. So that is in meter, you are going to get some 15.36 meter. So this is going to be your right answer. Okay, if they are asking round up to 1 decimal point, they will be giving a proper range only. If it is 2 decimals, some 3.5 to 3.8, something they can give. Okay, may not be very small range, whatever. Fine. So for this question, 15.36 will be your final answer. Always remember, properly substitute the C value. And in case if they are not mentioning any condition, calculate both and whichever is your maximum. That is going to be your final value of minimum base width. Okay, here since they have asked only for sliding, we are calculating only for sliding. Okay, hope you understood. Don't make any mistake for the next time. So let's move to the last question which is appeared in the afternoon session. They have given the field capacity, the permanent wilting point is also given, and consumptive use is given. Daily consumptive use is 2 mm. That's what the sentence, which means per day. Okay, depth of root zone is given, then they are asking the frequency of irrigation. So this question, according to the data, none of the options will be correct. Okay, they have given some options also, 7, 8, 10, 11 something. So none of the options will be correct. So this question is going to be cancelled this year. Okay, which means they will be finally normalizing it. Don't worry. Because according to the question wordings which they have used, what they have given that the irrigation water supplied when the moisture drops to 20%. Okay, moisture drops to 20% means your field capacity is 30%, your permanent wilting point is 13%. We know when we are going to give water, whenever the moisture content is dropping and finally reaching your optimum moisture content, which means your optimum moisture content is 20%. Okay, even though the question is going to get cancelled, very important, in many competitive exams they will be asking it, in your coming exams also. So I'm just telling you what should be the proper steps for doing such questions. We have done same type of questions in the gate booster sessions also. So we know the frequency of irrigation is nothing but the readily available moisture depth divided by the consumptive use of crop, right? So readily available moisture is nothing but the field capacity minus optimum moisture content. We have to convert in terms of depth. So what we have to do, we have to multiply with the specific gravity as well as the depth of root zone. Okay, multiply with S and D. Now see, divided with what is the consumptive use, they have given 2 mm per day. Okay, so the readily available moisture we have to calculate in terms of mm, so it will be mm per day. So according to the question, it should be 30%, means 0.3 minus 0.20 multiply with specific gravity. Okay, I think I have missed that data. Yeah, they have given for the soil, they have given in terms of 1500 kilogram per meter cube as well as 1000. So according to the question, the specific gravity is going to be 1.5. Okay, that I missed it to write. Okay, specific gravity 1.5. We are going to divide with the water also. So 1500 was given, divide with 1000. We are going to get 1.5. Okay, so 1.5 is the multiply with, they have given in terms of centimeter. I think here only they made some mistake, I guess. The value might be something else, maybe, I don't know. So 80 centimeter means 800 mm. If you are dividing with 2 mm per day, so this is going to be your solution according to this particular given data. But this is going to be wrong. You are going to get some very high value something. Okay, maybe some mistake happened in this portion or some mistake happened in this portion. Whatever it is, your answer is not going to get matched. So I'm not solving that. Okay, because your answer option are not going to get matched. So this question might be definitely they are going to cancel this and they will be normalizing it in your solutions, right? So hope you understood the solution just for your future exams and all. That's it. That are the entire questions appeared in hydrology and irrigation. We have discussed the entire questions. Okay, entire. We have not skipped anything. Entire questions here. Morning they have asked 2 marks, and afternoon they asked 5 marks. No? So 7 marks from hydrology and irrigation. See, the weightage is getting increased year by year. Even though morning they were not asking that much, afternoon they have increased like anything. So don't skip any topics from hydrology irrigation in your coming exams. It may be asking for more marks. Okay. So I hope you have understood all the questions which we have discussed, and I hope for all the 2020 aspirants your exams went well and your answers from hydrology and irrigation got correct. Okay. So we have done so many sessions for this subject. We will be doing the same for the coming days also. So keep on watching the videos. For that, subscribe the channel and click on the bell icon for some live sessions also. Share the video with your friends so that they can also check whether their answers are correct or wrong. Okay. So bye. Hope you like the video. If you like the video, we can show your love in terms of likes and comments. That's it. Okay. Bye everyone. Thank you so much.